Hi everyone, in this video I am going to discuss about the lanthanides and actinides. This particular topic contains a lot of text and a lot of information and less of explanation is needed. So I have made slides over here. I will be telling you all the important things from F block elements. It won't include each and everything from F block element, but it contains most important things which you needed. With the help of this, you can solve the problem very easily. I will tell you how to memorize the lanthanides and actinide series. You only need to remember one sentence. Through mnemonics, we can discuss the lanthanide series. Mnemonics. The first you should know what is mnemonics, right? Mnemonics are the memory tricks. They can help you to remember a long strings of information, often in a particular order. To memorize the lanthanide series, you can remember this sentence. That sentence is: lanthanide chemistry presents no problem since everyone goes to Dr. Hayes excruciatingly through yearly lectures. Okay, therefore here for lanthanide you can write La, for chemistry you can write cerium, presence you can write Pr, for NO you can write ND, that is neodymium. Then here problem you can write promethium. Then since you can write samarium. Then everyone you can write europium. Goes you can write GD. Then 2 you can write TB, terbium. Then doctor you can write it DY, and Hayes you can write HO, holmium. Then here excruciatingly you can write ER, erbium. Then through you can write TM, thulium. Then here yearly you can write ytterbium, and lectures you can write lutetium. Lanthanides are called first inner transition series or third transition and come immediately after the lanthanum. According to IUPAC or IUPAC, whereas 14 elements starting from cerium to lutetium without lanthanums are called lanthanides. In the bracket, meaning of the elements similar to lanthanum. 15 elements from lanthanum to lutetium are called lanthanoids. I hope you understood the difference between the lanthanides and lanthanoid. Like lanthanides, you can memorize actinides also. So you have to remember this sentence. This is very easy. You have to remember all these points which I am going to explain. Here the first point, that is lanthanides are characterized by the filling up of 4 of energy level which are not usually involved in the bonding. Next, binding energy of 4 of electrons are higher. Maximum oxidation state exhibited by the lanthanide is +4. Lanthanides are highly electropositive element, have common oxidation state, that is +3, and generally resembles each other in their chemical and physical properties. Next point, 4 of electrons have greater shielding effect, and fourth point, that is most of their ions are colorless. They are paramagnetic, but magnetic properties can be easily explained. Next point, they do not form the complexes easily. This is very, very important. You have to study this. Except promethium, they are non-radioactive. Their compounds are less basic. They do not form oxocation. Lanthanides do not form oxocation because the lanthanides have low charge density. Oxidation state and their stability. Oxidation state of Ln are based on their electronic configuration. The lanthanides have generic symbol, that is Ln. Whenever Ln is written, it is specified about all the lanthanides. If you know the mnemonics for lanthanides, very easily you can write the lanthanide series. Lanthanide chemistry presents no problem since everyone goes to Dr. Hayes excruciatingly through yearly lectures. Therefore, this sentence you have to study. The principal oxidation state of all the element is +3. Therefore, here common oxidation state, that is +3. Cerium shows +4 oxidation state, which is stable in solution as well. +2 oxidation state, that is stable in EU and YB, europium and ytterbium, due to 4F7 half filled and completely filled electronic configuration. Therefore, here you can see (4F) half filled. Then here also you can see 4F14. Here 4F7 half filled and completely filled. Therefore, stable oxidation state for EU and YB, that is +2 oxidation state. SM and TM also show +2 oxidation state in some cases. SM, samarium. So let's talk the next point. This slide shows you different colors of different lanthanide ions. There are different tripositive lanthanide ions. Their colors are given over here. You can just memorize the particular table. You can see one pattern. See over here, F0, F7, F14. All of them are actually colorless. Second important thing which you can look upon the table is that F2, F12 have similar color, F3, F11 have similar color, F4, F10 have similar color, F5 and F9 have similar color, F6 and F8 have similar color. Here F1 and F13 have similar color. Here Fn resembles F14 minus N. Both of them resemble similar color. Second important thing, oxidation number should have C. Next is the chemical properties. The first point, they readily tarnish in air and burn to give oxides. All give trioxide except cerium. Second point, they also combine with the following nonmetals: nitrogen, sulfur, halogens, etc. Next point, lanthanides also liberate hydrogen from water as does their hydrides, and vigorous evolution of same gas from dilute non-oxidizing acid. Next point, lanthanide compounds are generally predominantly ionic and usually contain lanthanide metal in its +3 oxidation state. Next I am going to explain the lanthanide contraction and the actinide contraction. Here, lanthanide contraction. There is a small regular decrease in atomic and ionic radii of lanthanoids is known as the lanthanide contraction. Next is actinide contraction. There is a regular decrease in atomic and ionic radii of actinoids known as actinide contraction. But this contraction is greater from the element to element due to poor shielding effect of fire of electrons. They show greater structural variability. The next is the chemical reactivity of the lanthanoids and the actinoids. The first one, they have less tendency towards the complex formation. Actinoids, they have strong tendency towards the complex formation. Second one, except promethium, they are non-radioactive. Actinides, they are radioactive. So much is there to describe, but I am going to stop here, otherwise it will take much time to explain. Now let us practice some CSIR previous year's questions. Here the question is, this question I have taken from 2017 December. December. Here the question is, consider the following statement for actinides. The first option, oxidation states greater than +3 are more frequent in actinide compared to lanthanide. This option A is correct. Due to more expansion of 5f orbital, actinides have more tendency to release electron, hence have more tendency to show oxidation state greater than +3 compared to lanthanide. Therefore, here option A is the correct answer. Option B, this is wrong. Then actinides show either FD or FF transition. But no DD. No DD transition. Therefore, here option B is wrong. Both are stable. Then option C is correct. Some actinides do not have radioactive isotope. This is also wrong. All the actinides have radioactive isotopes. Therefore, correct answer is option 1. This question I have taken from 2017 December. Here the question is 2017 December. Here the question is, match lanthanides in column 1 with their properties in column 2. Already I have explained, therefore further explanation is not needed. Therefore Lu, that is diamagnetic. A, oxidation state, this also you have to notice. Eu, B, Mi2 of metallic cluster. Then cerium, reagent in oxidation state 4. Then Tb, pink in oxidation state 3. Therefore, option 1 is the correct answer. This question I have taken from 2017 June. Here the question is, the calculated and observed magnetic moments of aqueous complex of lanthanide ion are 0 and 3.5 respectively. The lanthanide ion is. This is quite easy to understand. This is F6 configuration. One, 2, 3, 4, 5, 6, 7. Therefore, this was +3. Here +2, +1, 0, -1, -2, -3. F6, right? Therefore, here 1, 2, 3, 4, 5, 6. Here L is equal to 6 minus 3. Therefore, here S equal to 3. J equal to less than half filled. Therefore, here L, if it is less than half filled, here we have to write L minus S. Therefore, L minus S, that will be equal to 0. Here magnetic moment G square root of J into J plus 1. this will be equal to 0. Therefore here calculated and observed here in the question, calculated and observed magnetic moments of aqueous complex of lanthanide ions are 0 and 3.5. Therefore here option. Next question, match the fluorescence color given in the column A with lanthanide ions given in the column B. This question I have taken from 2018. The fluorescent colors of tripositive lanthanide ions. Here I am going to write LN, tripositive lanthanide ions. Fluorescence color SM, the color that is pink. EU, color is red. GD, orange in color. Then TB, green in color. DY, green yellow. HO, yellow in color. Then TM, that is blue in color. Therefore here option A is one is the correct answer. Pink. SM, red. This question I have taken from 2019 December. The question is, the pair of lanthanide ion which shows significant deviation between the experimental and calculated magnetic moments, considering the contribution from the ground state only. The configuration and magnetic moments are here GD3+, this is half filled. Therefore here 4 of 7, observed magnetic moment value that is 7.97, and calculated magnetic moment value that is 7.94. Then here the next is Lu 3+, 4F40. Observed magnetic moment value that is 0 and calculated magnetic moment value also 0. Then here Tb 3+, here 4F40, here 9.8, this is 9.7. Next is 3+, four F5. Here 4 of H, this is 4F5. Observed magnetic moment value 1.64, calculated that is 0.85. Next is 4F6, 3.36 and 0. Here the question is, the pair of lanthanide ion which shows significant deviation between the experimental and calculated magnetic moments, considering the contribution from the ground state only. Therefore here GD3+ and Lu3+ follow spin only formula. We can calculate n into n plus 2. While for remaining G, J into J plus 1 is valid. Question. Pair of lanthanide ions which show significant deviation between the experimental and calculated magnetic moments considering the contribution from the ground state only. Therefore, here option 4 is the correct answer.